So today, we're diving into something that is honestly pretty wild. We're looking at an AI agent that was basically dropped into one of the most complex, open-ended games ever made, and then taught itself how to play, explore, and master it, completely on its own. So let's get into how this digital pioneer managed to conquer a world with no instructions. All right, so first, we got to talk about the challenge itself, Minecraft. Now, this is not a game like chess or Go, with a clear winner and loser. It's a true sandbox. The researchers who built this thing called it a world with endless possibilities. You don't have a story you have to follow, you just explore, you build, you try to survive. For an AI, this isn't just a game, it's a nearly infinite universe, which is a massive, massive challenge. And that really gets us to the core question behind this entire project, right? How in the world do you build an AI that can thrive in an environment that never tells it what to do? Can you actually make an AI that learns to set its own goals, pick up new skills, and just keep getting better and better, kind of like a person would? Well, to tackle that exact question, a team of researchers from NVIDIA, Caltech, and a few other places developed Voyager. And it's really the first of its kind. It's an agent powered by a large language model, and it's specifically designed for what they call lifelong learning in exactly this kind of wide open world. And here's the key thing you got to get about Voyager. Its goal isn't to win the game. Its main mission, its prime directive, is to just keep exploring, keep learning new skills, and keep discovering new things, all without a human looking over its shoulder telling it what to do next. It's a totally self-driven, curious little agent. So how on earth does it work? The secret sauce behind Voyager can really be broken down into three brilliant core systems that all work together in this continuous, beautiful loop. Let's take a look at each one. First up, you've got the automatic curriculum. Now, the easiest way to think about this is as Voyager's own personal quest giver. It uses GPT-4 to look at everything Voyager has already done, checks what's in its inventory, and sees what's around it in the world. And then it comes up with a new, perfectly suited challenge. So, for example, if Voyager has a fishing rod and it's near a river, the quest giver might say, "New task, catch one fish." It's always pushing it forward, but never giving it something impossible. Next up is the skill library. This is basically Voyager's long-term memory. A better way to think of it is like a growing spell book. Every single time it figures out how to do something new, the code it wrote to do it gets saved in this library. So skills like craft wooden pickaxe or combat zombie are stored away forever, ready to be used again or even combined to tackle way more complicated stuff down the road. And the third piece of the puzzle is the iterative prompting mechanism. This is really the engine room. This is where the learning actually happens. Voyager writes a piece of code to try and complete its current task, but it almost never gets it right on the first shot. It runs the code, gets feedback straight from the game, error messages, what it sees, and it uses that feedback to tweak and refine the code over and over until it finally works perfectly. So, to put it all together, here's the cycle in a nutshell. The automatic curriculum gives it a task, the iterative prompting mechanism writes and refines the code to get it done, it gets feedback from the game and a little self-verification module, and then once the task is finally complete, that new skill gets saved to the library, and the whole loop kicks off all over again with a new task. And this is where you can see that abstract code turn into real action. On the left, you've got the actual JavaScript for a skill called combat zombie. It's got all the logic in there. Check for a sword. If you don't have one, make one, then go fight. And then boom, on the right, you see the result. That's Voyager in the game, ready to take on that zombie. Okay, so the system sounds really impressive in theory, right? But does it actually work any better than other methods? Well, the researchers put Voyager in a head-to-head competition with other top AI agent techniques like React, Reflection, and even AutoGPT. And the results? Well, they weren't just good, they were absolutely staggering. Just take a look at this chart. That orange line soaring way up high, that's Voyager. The horizontal axis is time, and the vertical axis is how many unique items it found. It's not even a contest. Voyager's ability to just explore and find new stuff is on a whole other level. It discovered 63 unique items. That's 3.3 times more than its closest competitor. I mean, look at the other lines. They just flatline. And what about efficiency? How fast is it? When it came to progressing through the game's tech tree, which is the main crafting progression in Minecraft, Voyager was an incredible 15.3 times faster at unlocking that first big milestone, wooden tools, than the next best agent. 15 times. And that early advantage just snowballs over time, as you can see in this full tech tree comparison. The other agents really struggled. Most of them never even made it past iron tools.
Voyager. Voyager was the only agent to successfully reach the highest tier and craft diamond tools. That's a massive achievement that requires this long, complex chain of skills it had to learn all by itself.
Visually, the difference is just as crazy. These maps are bird's-eye views of the worlds each of the AIs explored. Voyager's path, the one in orange, is just huge. It covers all these different types of terrain and travels for vast distances. The other agents, they're pretty much stuck in these tiny little areas, which, of course, really limits what they can discover. To put a number on it, Voyager traveled 2.3 times farther than its competitors. And this isn't just about aimlessly walking around. This means it has the skills and the self-directed curiosity to go out there, venture into new places, and find the new resources it needs to keep learning. So what does all this mean outside of a video game? Why does this really matter? Well, this is where it gets really exciting, because this research points towards a future for AI that goes way beyond just playing games. You see, the Voyager system is also incredibly flexible. The researchers showed that if you swap out that automatic quest giver for some instructions from a human, the agent could do really complex, creative stuff, like building another portal or even a simple house. This gives us a little hint of future applications where these kinds of agents could act as our assistants or collaborators in things like robotics, design, and even science. And that's the thought I really want to leave you with. Voyager is this powerful proof of concept for an AI agent that can learn continuously in a complex world without needing constant handholding. It really makes you wonder, if an AI can teach itself to explore and master a digital world as rich and unpredictable as Minecraft, what real worlds will it learn to master next?